Okay, now let's look at problem number 22. Sides AB and AC of equilateral triangle ABC are tangent to a circle at points B and C respectively. What fraction of the area of triangle ABC lies outside the circle? Okay, again, start drawing. Oops. Oh, this is actually better. So we have a equilateral triangle here. Yay. And it has A, B, and C as its vertices. Now side AB and AC are tangent to a circle at points B and C respectively. So we have a circle. Okay, let's just get a circle first to have an idea. And it is tangent to this line, at this point. So the circle needs to be here, and we know that the circle is tangent to this line here, so that this radius here needs to be perpendicular to the line AB. Okay, similarly, this is the same case with C. So this tells us that this triangle should probably be somewhere here. Oh, why doesn't it bend me? Okay, great. And we know that these two radiuses, or instead I should say these two radii, the plural form probably, and they are right angles here and here. Let's make it more beautiful. Great. Okay, what next? What fraction of the area of triangle ABC lies outside the circle? Okay, so it wants us to get the area of this part. Okay, quite difficult to draw. Let me just ignore all the fancy stuff. Okay, they want us to get the area of this part divided by the area of the whole triangle. Okay, so how do we calculate the area of this? It is better if we calculate the area of the green, the triangle ABC, and then we add this part, which is another triangle. Let's call it OBC, and then we have to minus the red parts. Okay, so blue part plus blue part plus blue part would give us this whole ABOC minus the red part should be these. Okay, minus the red parts, so ABOC minus the whole red parts would give us the green parts, and that's what we want here. So it doesn't really give us the length of any side here because we want to have a ratio, but for us to calculate it, it's better if we just give someone like a real length. Let's just say the radius of this circle is 1. So let BO equals to OC equals to 1. Then we know that AB would be, and also AC and also BC would be square root 3. You can think of it in several ways. You can draw a line here. You know that this has an angle of 60, and this line is like the symmetric line, so that these two angles should be the same, so they're each 30. You know that this is a right triangle, so this is a triangle with like 30, 90, and 60. So you know that the ratio of their sides should be 1 to square root 3 to 2. So if OB is 1, then AB is square root 3, and AO will be 2. Okay. Now we just need to calculate like the areas here. Okay, so yeah. Let's just call this place D. Okay, so if BO is 1, similarly the triangle BDO is a triangle like this here, so that we know BD would equal to this is 1, this is 1/2, so this is square root 3 over 2. Similarly, it will be DC. So BC would be square root 3. And also, yeah, we mentioned that AO would be 2. If we want to calculate the area of a kite, so that it is, I mean, if the two sides of the kite is the same, then it's a square. But like if one of them is like larger, the other one is shorter, but it's similar. I mean, it's the same thing on both sides. It is a kite. I'm sure you all know it because everyone's played kite before, I hope. And the area of the kite should be this length times this length times 1/2, because if you just do distance times distance, then it's basically calculating the area of this whole rectangle. These are same, these are the same, these are the same, so that you're actually taking half of it. If you don't know how to calculate it, just calculate each triangle, add them up. No big difference, it's just useful to know. So the area of the blue parts should be BC times AO times 1/2. So it is square root 3 times 2 times 1/2, and it's square root 3. Okay, what about the red area? So this angle is 120 degrees. It is 1/3 of 360 degrees. So the area of the white, the area of the, red places, it's 1/3 of the total circle. So the total circle is pi r square. R is 1, so it's just pi 1 square times 1/3. It is pi over 3. And yeah, now we have it. Now we just need to use the blue area. Oh yeah, we have to calculate triangle ABC first. So triangle ABC would be BC times AD times 1/2. BC is square root 3. AD would be AO minus DO. DO here is 1/2. AO is 2. I just write it somewhere here. So AD is 2 minus 1/2. It will be 3 over 2. 3 over 2 times this. It gives us 3 square root 3 over 4. Okay, so finally, the green parts should be, okay, blue minus red. Blue minus red. And then the ratio should be S green over S triangle ABC. That is square root 3 minus pi over 3 over 3 square root over 4. And yeah, basic calculation. I have no place to write it anymore, but if you just simplify it, you will find out that the answer to this question is D. Yeah, so it's not a difficult question. So it's important that you draw this out and understand, like, if you can draw it out, it means that you have understand the problem because it's describing stuff in words. And then you just need to calculate with patience. Because it's very easy to like did something somewhere and you don't want that.